Welcome back to this series of videos called PSLE Science Q&A with James. In these videos, I answer questions that my students post to me, or it can be questions posted to me by any students who need help with science. Let's get started. It is always a good reminder that you will send me pictures of good quality. Make sure that they are not covered in shadows. That makes it easier when I go through the answers with you. Alright? Now, Sherry poured the same amount of liquid X but at different temperatures into two identical cups. She then placed a metal spoon into each cup and measured the temperature of the spoon after 5 minutes. So we notice that it's a cup with spoon, and we know that the amount of liquid is the same, the temperature is different. Now, and metal is a good conductor of heat. Now, spoon A, before experiment, the temperature of the spoon was the same at 30 degrees Celsius. At the end of the experiment, the temperature of the spoon changed. For spoon A, it increased to 41 degrees Celsius, which means that the liquid inside cup A must have been a hot liquid. Whereas the spoon B registered a lower temperature at 20 degrees Celsius. Temperature dropped. So the temperature of the drink in cup B must have been a cold drink, a low temperature drink. Now, which of the following shows the likely temperature of the liquid in cup A and B? Now, one of the concepts here will definitely be heat travels from a place of higher temperature to a lower temperature. For this spoon A to gain heat and is registered by an increase in temperature, that means that the liquid in cup A must have been higher than 30 degrees Celsius. So it's either 1 or 2. And then the liquid in cup B must have been one of lower temperature. So that would be a temperature that is below the temperature of the spoon at first, below 30 degrees Celsius. So that will be 1. And the answer for this is 1. Let's take a look at the next question. The table below shows the states of 4 substances, A, B, C, and D at different temperatures. So 4 substances and their states. States refers to solid, liquid, or gas. Alright, at 5 degrees Celsius, A is a liquid. At 50 degrees Celsius, A is a liquid still. At 100 degrees Celsius, A has become a gas. Now, does it mean that the liquid boils at 100 degrees Celsius? It does not mean that. But it does mean that the liquid A boils at any temperature between 50 and 100. Now, let's take a look. B is gas throughout. So then for B, it was at a liquid state at a much lower temperature than 5 degrees Celsius. Interesting things. So not everything that you learn is about water, where melting and freezing point is at 0 degrees Celsius, boiling point is at 100 degrees Celsius. They can give you matter that have different states at different temperatures. Now, based on the information above, which of the substances have the highest melting point? Remember, melting point is the same as freezing point in terms of the value. When we talk about melting point, we're thinking of if this is melting point or freezing point, anything below this will be your solid. If we heat the solid up, heat it up until it reaches the melting point, it melts, and then at this point here, it becomes a liquid. If this liquid continues to gain heat, then at a certain temperature, it will boil and then becomes a gas. Alright, and when it becomes a gas, that is when it will change the state, and of course, this part will be your boiling point. They're asking us for the highest melting point, which means it remains at a solid even at very high temperature. So at 5 degrees Celsius, I see C at a solid. At 50 degrees Celsius, D is still a solid. At 100 degrees Celsius, D is still a solid. So you see, even if I heat up this substance D to 100 degrees Celsius, it still hasn't melted yet. That means that D has the highest melting point, definitely above 100 degrees Celsius. So the answer is 4 for this question. Okay, this picture is really blurry. I'm trying my best to help. Let's see if I can help you. An object is placed between, I suppose this is a torch and a screen. Alright, torch and screen. Object is here. Touch screen. So this is object. Now, of course, then whether it looks like a dark shadow to me, so it must be an opaque object. Now, which of the following graphs shows the relationship? I'm not sure what is this word. Relationship between x, y. I think this is h. So x should be this, y is this distance, h is the height of the shadow. So typically for such questions, right, the height of the shadow, if I'm going to write it down in the table for you to see, x is the distance between the torch and the object. Y is the distance between the object and the screen. H is the height of the shadow. Now let's take a look at a few permutations, a few combinations of these to try to recall what you learned about this in P4 when you learned about light energy. Let's say I keep this distance, but see it's all about x and y, right? X and y, x and y, x and y, and height here. So let's say I want to increase the height of the shadow. To increase the height of this shadow, I can move the object nearer to the torch. That means that my distance x have to decrease, and the distance y, if I move this over here, that means while x decreases, y at the same time will increase. Understand this? Alright, so if my height were to decrease, that means that if I move the object nearer to the screen, so y will decrease in distance. As y decreases, x of course naturally increase. How does a graph like the first one look like? So if I talk about height of the shadow, as height increases, so I say as distance y increases, as y increases, all right, then my height will increase. So I expect to see a y graph that goes up, and this part corresponds to my height. Let's check for y that goes upwards first. When y goes down, that's wrong. Y goes up, yes, we have a chance here. Y goes down, that's wrong. Y goes up, that's correct here. Right, and this height. And notice the relationship. As y increases, x decreases. Here, this is wrong because as y increases, x also increases. This is wrong. Okay, so let's have this. As y increases, x decreases, which is what we talk about here. The answer is 4 for this. Substance Q freezing point is 35 degrees Celsius and boiling point is 70 degrees Celsius. This question is very common, this kind of question at PSLE. So you must learn how to master doing such question. Now, freezing point is the same as melting point in terms of the value 35 degrees Celsius. The meaning, of course, is different. Freezing means it changes state. Q changes state from liquid to a solid at 35 degrees Celsius. Whereas melting point means Q changes state from a solid to a liquid at 35 degrees Celsius. But the number value is the same for both melting and freezing point. So if I were to draw my working line here, and this is solid, this is liquid, this is gas, 35 degrees will go here. Okay, so this point is where solid changes to liquid, melts, or when liquid changes to solid, it freezes. Boiling point is at 70 degrees Celsius. So at this temperature, liquid changes to a gas, it boils. So Q at 30 degrees Celsius, where is 30? 30 is here. This is 30 degrees Celsius. So it is a solid at 30 degrees Celsius. So it must be solid, solid. And how about at 80 degrees Celsius? Now 80, where's 80? 80 is here, right? This is where 80 is, above 70. So that will be a gas. So gas. So answer is 2 for this question. Okay, next one. Okay, the question the child asked me is, why is answer not 4? Well, I already explained why it has to be a solid state at 30 degrees Celsius, right? It is below the melting point, so it stays as a solid. It cannot be a liquid at 30 degrees Celsius because this substance does not melt until it hits 35 degrees Celsius. Okay, Now let's go on to the next question. Alright, another blurry question. I'll try my best, alright? Now Mutu conducted an experiment with different springs A and B. So it's spring A and spring B of the same length. I'm going to assume, because I can't really see the words, I'm just going to pretend I can see the words. Same length. Okay, I cannot see any of these words here. So I suppose that this is the spring. There's a pin. The pin is used to like point to the part here, and this part is usually at 0. The pin helps you to measure, help you to read this distance more accurately. There's a mass hung to the end of the spring. Now, he measured the extension. Now, extension, take note girls and students, alright, and extended length. These two words have different meanings. If I have a spring, this is the original. And then I hang something to it to make it heavy, having heavy at the end. So what do we call this length? Okay, and what do we call this length? Which word goes to which part? This part is the extension. This part is the extended length of the spring. Okay, so it says that spring A extension is 1.5 cm. When you add 100 grams of mass to it, we add 200 grams of mass, spring A's extension, this part will go to 3.2. When you add 300 grams, it goes to 7.1. And B, now remember these two springs were at the same length at first, same original length at first. So we add 100 grams, it extended to 2.9. So this extension was greater than A. That tells me that spring B is less stiff than A. It's a less stiff spring. When you add 200 grams, it goes to 5.5 centimeter. At 300 grams, it goes to 10.2 centimeters. So the heavier the mass, so based on this result, state the relationship between what? Between the mass and the extension of spring A. Alright, so the greater, now usually I don't like to use the word heavier, because heavier here is specifically used to talk about weight, and weight is used to talk about force. So in this case here, I'll prefer if you talk about something else, which is the greater the mass of A, which is greater the mass of A. Talk about extension, the greater the extension of spring A. Name the forces acting on the spring when it's hung on the spring. There are two forces. One force pulls it down, that is the gravity, which you got it right. Another one that pulls it up, and that will be the elastic spring force in the spring, and you also got it right. Next one. Mutu used spring A to make a toy. Looks like this Jack in the Box toy, okay? When Mutu opened the box, the toy spider jumped out. So this spring must have been compressed at first. The lid on top, alright, stops the spring from fully extending to its original length. It compresses it. So when the lid is open, then the spring is able to return to its original length, and it pushes the spider upwards. So what is the main forms of energy of the toy spider when it jumps out? Clue is when it jumps out, alright, then jumping is a movement, so that means that and they say main forms as an S here. Well, strangely, I think the answer should be kinetic energy. But why does it say main forms? I think it's an S, I think. So it should only be kinetic energy. Now, you can definitely, but if you say S, it forces me to give one more answer. Then I may have to give potential energy, because it has mass, a toy spider has mass, and as it increases in height, the potential energy increases in the spider. But actually, when we talk about movement, it's just kinetic energy. So here, if it says forms as, and it's not bracketed, okay, then I would give just 1 if it's this. But since it forces me to give more than 1 with an S here, I will give this as well, energy. Next, move to change spring A to spring B. Remember, spring B is less stiff. If it's less stiff, it will have less elastic spring force when it is compressed. A less stiff spring has less elastic spring force and is being compressed. So, move to change spring A to spring B. Place a toy spider back into the box. So it will definitely, if the spring is a less stiff spring and it has less elastic spring force, then the spider will spring up to a lower height. Okay, not higher. So the first is your claim. Alright, it's a lower height. The spider will jump to a lower height. Why? First, talk about the evidence. The evidence from the table tells you that the spring B is less stiff than A. Therefore, what's the reason? Let me improve my handwriting here. So the reason is, so why would this make the spring go to a lower height? A less stiff spring has less elastic potential energy in it when it is compressed compared to a stiffer spring. So that's my reason for it. So I should get 0 mark for giving the correct claim. Alright, I should get 1 mark for giving the evidence and 1 mark for the reasoning. I want to bulletproof my answer. So what does it mean here? So when it has less, so with less elastic potential energy, okay, I will just change it to the less elastic potential energy in the spring will convert to less kinetic energy in the spider, moving it a shorter distance upwards, which explains the lower height. Okay, the lower height, which is my claim. Alright, that's how I'll answer this question. Well, I hope this helps. If you have questions about PSLE science, do send them to me and I'll do my best to help you. I'm very busy with my own students, so I probably can only get back to you in about a week's time. Alright, I will make such Q&A videos over the weekend to respond to any questions that the students send to me. So, meanwhile, take care, stay safe, and study hard. Goodbye.